Hello friends, welcome back to our channel. In this video, we are going to solve a few set of problems related to vectors. Let's start with the first problem. Here, we are given two vectors. A vector is equal to 3i cap plus 2j cap minus 4k cap, and b vector is equal to 2i cap minus 3j cap minus 6k cap. We have to find the dot product of these two vectors, a vector and b vector. That is, we have to find a vector dot b vector. We know that if we are given a vector is equal to a1 I cap plus a2 j cap plus a3 k cap, and b vector is equal to b1 I cap plus b2 j cap plus b3 k cap, then their dot product is given as a vector dot b vector is equal to a1 b1 plus a2 b2 plus a3 b3. Using this direct formula, we can solve this problem. Therefore, a vector dot b vector is equal to a1 b1, which is 3 multiplied with 2. 3 multiplied with 2 plus a2 b2. Here a2 is plus 2 and b2 is minus 3. 2 multiplied with minus 3 plus a3 b3. Here a3 is minus 4 and b3 is minus 6. So minus 4 multiplied with minus 6. So here we are getting 3 multiplied by 2 is 6 minus 3 multiplied by 2 is 6. Here we are getting plus 24. Both these terms get cancelled, so we are getting 24 as the answer. Now let's proceed to question number 2. Here we are given a vector as 3i cap minus 2j cap plus k cap, and b vector as 2i cap plus 6j cap plus mk cap, where m is a scalar number. Now we are required to find the value of m if we are given that a vector is perpendicular to b vector. That means if a vector is b vector, then b vector is perpendicular to this vector as given in the question. Now we know that we have learned the previous concept. Previously we have learned that if two vectors are perpendicular to each other, then their dot product is always 0. So we can write, since these two vectors are perpendicular to each other, therefore their dot product is going to be 0. Therefore a dot b is going to be 0. So here we are getting 3 multiplied by 2 plus minus 2 multiplied with plus 6 minus 2 multiplied with 6 plus here 1 multiplied with m is equal to 0. So we are getting 3 multiplied by 2 is 6 minus 6 multiplied by 2 is 12 plus m is equal to 0, or m is equal to 6. This is the answer of this question. Therefore the value of m is 6. Now in question number 3, we are given that a vector is equal to I cap plus j cap plus k cap, and b vector is equal to minus 2i cap minus 2j cap minus 2k cap. We are required to find the angle between a vector and b vector using these two given situations. We can make use of the dot product to find the angle between these two vectors. We know that a vector dot b vector is equal to magnitude of a vector multiplied with magnitude of b vector multiplied with cos of the angle between them, that is theta. Let the angle between them is theta. Here we can write a dot b 1 multiplied with minus 2 plus 1 multiplied with minus 2 plus 1 multiplied with minus 2 equal to magnitude of a vector. Magnitude of a vector is simply square root of 1 square plus 1 square plus 1 square. 1 square plus 1 square plus 1 square multiplied with magnitude of b vector, which is square root of minus 2 square plus minus 2 square plus minus 2 square. Multiplied with cos of the angle between these two vectors. In the left hand side we are getting minus 2 minus 2 minus 2, which is minus 6, that is equal to square root of 1 plus 1 plus 1 3 root under 3 multiplied with this is 4 3 is 12 root under 12 and cos of theta. We can write it as 4 multiplied with 3 and the 4 will come out of the square root, so giving us minus 6 multiplied with root 3, this is 2 root 3 cos of theta. Now root 3 multiplied, then we are getting 3, so 3 multiplied with 2 is 6, so cos theta is basically minus 1. Cos theta is equal to minus 1. Now we know that cos of 180 degree is equal to minus 1. Therefore, theta is equal to 180 degree. That means both these vectors are pointing in opposite directions. This is the answer of this question. In question number 4, we are given that if the sum of two unit vectors is a unit vector, then we are required to find the magnitude of their difference. Let the two unit vectors be a cap and b cap. Let the two unit vectors be a cap and b cap. According to question, these two are unit vectors. Therefore, we can write magnitude of a cap is equal to 1 and magnitude of b cap is equal to 1. Now, we are given that the sum of the two vectors is also a unit vector. Therefore, magnitude of a cap plus b cap is also going to be 1. Because sum of the two unit vectors is a cap plus b cap and it is also a unit vector. So, the magnitude of this vector a cap plus b cap is going to be 1. Now, we are required to find the magnitude of their difference. That means we are required to find magnitude of a cap minus b cap. Its direct formula is square root of magnitude of a cap square plus magnitude of b cap square minus 2 times magnitude of a cap magnitude of b cap multiplied with cos of theta, where theta is the angle between a cap and b cap. Theta is the angle between a cap and b cap. Now, we know magnitude of a cap is 1, magnitude of b cap is 1. The only unknown thing is theta. That means we have to find the value of theta from this given statement, so that we can use the value of theta to find the value of magnitude of a cap minus b cap. Now, here we can write square root of, we know the direct formula, magnitude of a cap square, which is 1 square, plus magnitude of b cap square, which is also 1 square, plus 2 times magnitude of a cap, which is 1, magnitude of b cap, which is 1, cos of the angle between these two vectors a cap and b cap, which we have already assumed to be theta. So this is equal to 1. Let's solve this. Squaring both sides as ds, that means squaring both sides, we are getting 1 plus 1 2 plus 2 plus 2 cos theta is equal to 1, or cos theta is equal to 1 minus 2 is minus 1, or we can get minus 1 upon 2. We can directly use the value of cos theta in this expression. Square root of 1 square plus 1 square minus 2 times 1 1 cos theta, which is equal to minus 1 by 2. Minus 1 by 2. So here we are getting 1 plus 1 minus, these 2 get cancelled, minus minus plus, which is 1. So we are getting magnitude of a cap minus b cap as root under 3. This is the answer of this question. In question number 5, we are given that by vector method we have to prove that if the diagonals of a parallelogram, this represents a parallelogram, intersect perpendicularly, then the parallelogram is a rhombus. Let us first draw a parallelogram. Here suppose this is a parallelogram PQRS. Now we are given that the diagonals of this parallelogram intersect perpendicularly. That means the diagonal PR is perpendicular to the diagonal QS. Now we are required to prove that this parallelogram is a rhombus. Now we know that a rhombus is any quadrilateral whose all sides are equal. So let us assume this PQ as A vector and this PS as B vector. We have to prove this using vector method. So we are assuming these two vectors. Then if this is B vector, then this is also B vector, and if this is A vector, then this vector is also A vector. Now by triangle law of addition we can see that this A vector plus B vector is going to be this vector, which is this vector. This is A vector plus B vector. Now QS vector is basically B vector minus A vector, because by triangle law of addition we can see that this A vector plus B vector minus A vector is going to be this resultant B vector. By triangle law of addition we can easily see this concept. Now we are given that these two lines are perpendicular, therefore A vector plus B vector is perpendicular to B vector minus A vector. So we can make use of the dot product concept. Therefore A vector plus B vector dotted with B vector minus A vector is going to be 0, since these two vectors are perpendicular to each other. Now let us open the brackets. A vector dot B vector, A vector dot B vector minus A vector dot A vector plus B vector dot B vector minus B vector dot A vector is equal to 0. Now we have learned that dot product is commutative, therefore A vector dot B vector is same as B vector dot A vector, therefore these two terms get cancelled. And we have also learned that A vector dot A vector is basically magnitude of A vector ka whole square. Therefore we are getting minus of magnitude of A ka whole square plus magnitude of B ka whole square is equal to 0, or magnitude of A ka whole square is equal to magnitude of B vector ka whole square. From here we can see magnitude of A vector is equal to magnitude of B vector. Therefore these two adjacent sides are equal, therefore all sides are equal, therefore this quadrilateral is a rhombus, hence proved. Next question is question number 6. Here we have to find the magnitude and directions of the vectors I cap plus j cap and I cap minus j cap. Let's understand this question first by drawing the figure. Suppose this is x axis and this is y axis. Then I cap is the unit vector along the x axis. Suppose this vector is I cap. I have assumed this is of magnitude 1, that means this length is 1 unit and its direction is along the x-axis, positive direction of x-axis, and j cap is the unit vector along y-axis. Now I cap plus j cap is the resultant of these two vectors. The result, by parallelogram law of addition, we can complete this diagram, and the diagonal vector is going to be I cap plus j cap. Now I cap minus j cap means the resultant of I cap and minus j cap. So we have here I cap. Now we have to draw minus j cap. This is minus j cap. These two lengths are same, and the resultant of I cap and minus j cap is this vector, which is I cap plus minus j cap, which is basically I cap minus j cap. Now let us first find the magnitudes of these two vectors. Now magnitude of I cap plus j cap is equal to square root of, we can use the direct formula, magnitude of I cap ka square, which is 1 square, plus magnitude of j cap ka square, which is 1 square, plus 2 times magnitude of I cap, which is 1, magnitude of j cap, which is 1, cos of the angle between the two vectors, which is the angle between I cap and j cap is 90 degree. Now we know that cos 90 is 0, therefore this term gets cancelled. So we are getting root under 2. Similarly, we can find the magnitude of I cap minus j cap is equal to square root of magnitude of I cap ka square, which is 1 square, plus magnitude of j cap ka square, which is 1 square, minus 2 times magnitude of I cap, magnitude of j cap, cos of the angle between I cap and j cap, which is 90 degree. Again, cos 90 is 0, therefore this term gets cancelled, and we are getting square root of 2. That means the magnitude of I cap plus j cap is also root 2, and the magnitude of I cap minus j cap is also root 2. From this diagram also we can see this, because since I cap is a unit vector, this length is going to be 1. Similarly, this length is going to be 1. By Pythagoras theorem, we can find this length. Since this length is 1, this length is also 1. So 1 square plus 1 square is going to be the magnitude of this ka whole square. Therefore, this is going to be square root of 2. Now, we have to find the directions of these two vectors. Suppose we can denote directions in any ways. Suppose we can denote the direction of this vector as this angle theta, which it is making with positive direction of x-axis. Suppose this is theta 1, and suppose this vector makes an angle of theta 2. This angle is theta 2 with which this vector I cap minus j cap makes with the positive direction of x-axis. From this direction we can write, from this figure we can write tan theta 1 is equal to this length upon this length, which is 1 upon 1 is equal to 1. Therefore theta 1 is going to be 45 degree. We have also learned in previous sections that if these two are of equal magnitudes, then if these two vectors are of equal magnitudes, then the resultant passes through the angular bisector of this angle, this whole angle. The resultant passes through the angular bisector of this whole angle. Similarly, we get theta 2 as 45 degree. So we can denote the vector as I cap plus j cap is a vector of magnitude root 2, and it passes 45 degree, which it makes with a positive direction of x-axis in anti-clockwise sense. Now, in question number 7, we are asked to find the components of a vector, which is 2 I cap plus 3 j cap, along the direction I cap plus j cap and I cap minus j cap. Suppose this is B1 vector and this is B2 vector. Then we are required to find the component of a vector along B1 vector and component of a vector along B2 vector. Now we know that suppose this is a vector and this is B vector, then this is termed as the component of a vector along B vector. We know its direct formula is a vector dot B cap. If we are required to find the magnitude of components, then we have to take mod also, so that the result or outcome is positive or 0. It should never be negative. Now, since we are asked only the components and not magnitude of the components, we are not taking a mod of this value. So, projection of a vector, not projection, component of a vector, or it means the same thing, component of a vector along the direction b1 vector is basically a vector dot b1 cap, which is equal to a vector dot b1 cap means b1 vector divided by magnitude of b1 vector. So here you can see a vector dot b1 vector, which is 2 multiplied with 1 plus 3 multiplied with 1 divided by, this is a vector dot b1 vector divided by magnitude of b1 vector, which is square root of 1 square plus 1 square. Here we are getting 2 plus 3 as 5 upon root 2 units. This is the answer of the first part. Now, if we are to find the component of a vector along b2 vector, then we have to do the similar thing, that is a vector dot b2 cap. Let's write the answer in this side. A vector dot b2 cap, which is basically a vector dot magnitude of b2 vector divided by magnitude of b2 vector. Here, let's do the dot product of a vector dot b2 vector, which is 2 multiplied with 1 plus 3 multiplied with minus 1. 2 multiplied with 1 plus 3 multiplied with minus 1 divided by magnitude of b2 vector, which is root under 1 square plus minus 1 whole square. Here we are getting 2 minus 3 as minus 1 upon root 2 units. Therefore, 5 upon root 2 is the component of a vector along b1 vector, and minus 1 upon root 2 units is the component of a vector along b2 vector.